Use the ALEKS calculator to evaluate each expression. This first one, log 4 divided by 5, the log key is right here, and this is log base 10. The natural log key is below it, and that's ln. So log of 4 divided by 5, and ln of 26.4. So negative nearest thousandths would be 0.097. And 3.273. Rewrite each as a logarithmic equation. 6 to the negative 1 equals 1 over 6. This would be log base 6 of negative 1, of 1/6 equals negative 1. Logarithms are the inverse of exponents. The bases are the same. The log equals the exponent, so the log equals negative 1. Log base 6 of 1/6 means 6 to the negative 1 power is 1/6. We take this log base 4 of 64 equals 3. This means that 4 cubed is 64. Rewrite as an exponential equation. Ln of x equals 4. Ln is log base e. So this is e to the 4th equals x. And this one would be ln of 6 equals y. Log base 7 of 7. If we hit math and go to log base 7 of 7 is 1, which means that 7 to the first power is 7. If we do log base again, log base 3 of 1 over 27, we get negative 3, which means that 3 to the negative 3 is 1 over 27. Solve for x. So 9 to the negative 2 as a fraction is 1 over 81. If we wanted to check our answer, we could use the log base 9 of 1 over 81 equals negative 2. Below is the graph of log base 4 of x. Translate it to become the graph of log base 4 of x minus 3 minus 1. Really, we just need to know that this moves right 3 and down 1. So click it, go right 3, 1, 2, 3, and down 1, and you're good to go. Graph the logarithmic function. So 3 plus log base 2 of x There's an asymptote here at x equals 0. So let's draw on that vertical asymptote right here. We want to put 2 points on the function. So let's look to our table, see if we can find something. 1, 3, and 2, 4. Graph a function, and we're all set. Graph the function 1 plus log base 4 of x minus 2 and give its domain and range using interval notation. So 1 plus log, let me start that over. 1 plus log base 4 of x minus 2. The vertical asymptote is at 2. So let's try that in first. Looks like it also wants us to put the points in. So let's look at our table, find some points. 3, 1, 6, 2. The domain means that it has to be more than 2. So 2 comma infinity. And the range is all reals, so negative infinity to infinity. Find the values to make these equations true. So we've got some properties of logarithms. So 7 times 5 is 35. When you add two logarithms with the same base, you multiply their insides. When you subtract, you divide. So 4 log base 4 minus log base 7 of 3 would be 4 over 3. And we have this power rule. So if we're cube rooting it, that would be 2, because 2 to the third is 8. Use the properties to expand. So log y plus 3 log z. The big square root is a half power. So 1/2 log of x plus 7/2 log of y minus 3/2 log of z. When we multiply, we add. When we divide, we subtract. And any powers we can bring down in front. This is x to the 1/2. This is y to the 7/2. And this is z to the 3/2. Use the change of base formula to compute. So the change of base formula, I'll show in just a second. If we just go ahead and use the log base key, you see log base 7 of 3 is this value, because 7 to that power is about 3. There's this formula that if we do log of 3 divided by log of 7, it'll give us the same value, 0.565.